Okay, welcome to our third class for the unit that we're currently into, factors and products. So we're going to review the two previous concepts of the two previous units: factors, multiples, squares, cubes, and roots. Review of concepts. So I'll be reviewing the concepts, and then I will be assigning an assignment of those concepts that will count for marks. So let's first of all review greatest common factor. And the numbers I'm going to use for examples of this are 20, 25, and 30. Factors are the numbers that multiply to make a number. For example, 4 times 5 make 20. Therefore, 4 and 5 are factors of 20. So the factors of 20, you can go in order, right? You can do them in pairs. 1 times 20 is 20. 2 times 10 is 20. 3 doesn't go. 4 goes. 4 times 5 is 20. Then we can go 6, there's nothing. 7, there's nothing. 8, there's nothing. And then 10. As soon as 10 shows up again, we know we're finished. There's going to be no more. And there's going to be nothing higher than 20. Okay, so for 25, we have 1 and 25, 1 times 25. 2, there's nothing. 3, there's nothing. 4, there's nothing. And then we have 5 times 5. So 1, 25, and 5. 6, nothing. 7, nothing. 8, 9, 10. We've gone up fairly high and not found anything. We know we're finished. 30 is going to have more. You have 1 and 30. We're going to have 2 and 15. We're going to have 3 and 10. 4 doesn't go. 5 goes with 6. 5 times 6 is 30. We don't have to do 6 and 5. That's the same thing. 7, 8 don't go. 9 doesn't go. 10 goes with the 3. That's when we know we're finished. That's when we have all the factors of 30. So what is the biggest number that the greatest factor that all these three have in common would be 5. 5, it shows up 3 times here, and it's the biggest one. They all have 1, but 1 is not the biggest. We're looking for the biggest one that they have in common. So the only ones that all 3 of them have are 1 and 5, and so we simply say that the greatest common factor equals 5. And the next step, next concept, LCM, lowest common multiple. And again, we do 20, 25, and 30. I'm just going to use the same numbers for the example here. Lowest common multiple, when you the multiples of 5, 10, 15, 20, multiples of 10, 10, 20, 30, those are the multiples of a number. In other words, they're times tables. So let's make a list of multiples of 20. 40, 60, I'm just counting by 20, that's all I'm doing. 80, 100, 120, 140, 160, 180, 200. So there's a list. Let's do 25 now. 50, 75, 100, 125, 150, 175, 200. So we've got those to the same point. Let's see where we can get with the 30. 30, 60, 90, 120, 150, 180, 210. So we've got them all to the same point, and we still don't have a common factor here. Still don't have a number that shows up in all three categories. 30 and 20 both have 120, but 25 does not. Okay, let's keep going. And obviously it's going to be something in the 25 category that ends in 0. Right? Because the 20 and the 30 are never going to have any numbers that end in 5. So 25, 225, 250, 275, 300, I'm running out of space here, 210, 240, 270, 300. Let's see if the 20 will get us to 300. What I'm going to do is simply move up above here and do 220, 240, 260, 280, 300. Yes, we got it. So the lowest common multiple of 20, 25, and 30 is 300. Now, it would be better if I'd moved these further over before I started. I should have been thinking about how much room I would need, but still, I think you get the idea. You have to list your multiples until you find the one that they have in common. Unless you're some sort of certified genius and can do them mentally. The next concept that we did was using common multiples when we're working with fractions. So for instance, let's just say fraction concepts. You've done this before. So, but I'm going to run through a couple of examples. You've done this in lower grades. 3/5 add 3/6 we'll do. We need a common multiple of 5 and 6. So multiples of 5, 10, 15, 20, 25, 30, 35. Multiples of 6, 12, 18, 24, 30, 36. Aha, I said 30 for both of them, didn't I? So the lowest common multiple of 5 and 6 is 30. That's what I'm looking for. I'm going to have to change both of these to a 30 to give them a common denominator. 5 times what is 30? It's 5 times 6. And 3 times 6 is 18. This becomes 18 30ths. 6 times what is 30? 6 times 5. This becomes 3 times 5.
So it took assessment of behaviors. You get down of 7 to 12 grades.
Just on the grading scale, not in the comments.
Okay, but it's always done.
Yeah. 18 30ths adds 15 30ths. Once we've done common denominators, all you have to do now, you don't add the denominators, just add the 18 and the 15, which are 33. So we're going to get 33 over 30. It's an improper fraction. We can clearly pull out a whole number here, right? For 30, pull out a whole number. So now we're at 30 and we have 3 more left. 1 and 3/30ths. Now this can be reduced. The 3 and the 30 both divide into 3. So 3 divided by 3 is 1, and 30 divided by 3 is 10. Include the 1, 1 and 1/10. So 3/5 add 3/6 equals 1 and 1/10. Let's do another example. We go with Baco. Now where were they? Let's do a subtraction. 13/5 minus 4/7. Now once again, I'm looking for a lowest common multiple. 5, 10, 15, 20, 25, 30, 35, 40. Now let's check the 7. 7, 14, 21, 28, 35, 42. Notice I said 35 for both of them. So I am looking for 35. 13 fifths into 35. And 4 sevenths into 35. 5 times what is 35? 5 times 7. 13 times 7 is 91. 7 times what is 35? Times 5. So 4 times 5 is 20. Then we have 91 over 35. Add 20 over 35. And we do 91 add 20. That's 101, 111. 111 over 35. Now how many whole numbers can I get out of here? Let's try 35 times 3. 35 times 3 is 105, right? Let's write that down. 35 times 3 is 105. So ich bin nun bei 111, so I can get 3 whole numbers out here. Then from 105 to 111 is 6. 3 and 6 35ths. Can I reduce this fraction? 35 only goes into 5 and 7, and 6 doesn't go into either of those. So we're done with that one. So that's the fraction work. Let's look at square roots and cube roots. Let's find the square root of 625. So what's a way of doing it? Well, in other words, what are the two numbers that multiply to make 625? It is a perfect square, so you can definitely do that. If you start 10 times 10, that's 100. So obviously you're nowhere close yet, so you know it's not 10. Right, so you try it. 10 times 10 is 100. So that's not there yet. 20 times 20 is 400. See, I'm just doing the easy ones to find out where I'm at. 30 times 30 is 900. So I know that it's somewhere between 20 and 30, but what is it? So now I know what my range is. I'll just proceed with my calculator. And I'm probably not going to start at 21 because it's probably going to be higher than that. So I'll start at 23 times 23. 529. I must be getting close. 24 times 24. Not yet. Must be the next one though. So once I know what my range is, I can go ahead and try and find it. And it turns out to be 25 times 25 is 625. So, and therefore the square root of 625 is indeed 25. And sometimes you simply have a square root memorized. You know, you might already know that the square root of 36 is 6. But the bigger the number is, the more difficult. Let's do the square root of 900. So again, do some checking. 10 times 10 is 100. I'm going to be bigger than that. 20 times 20 is 400. Bigger than that. So again, we'll check 30 times 30. Obviously. Because 3 times 3 is 9, so that's 900. So there, I didn't even need my calculator. The square root of 900 is 30. Just happened to be one of those nice round 0 numbers. Let's do another number. Let's do the square root of 225. So once again, I'm going to start with 10 times 10 is 100. Then I'm going to jump up to 20 times 20. That's 400. Hit SIGI immediately. It has to be somewhere between 10 times 10 and 20 times 20. So what is it? I'm going to start with 12. 12 times 12, that's 144. No, it's not that one. 13 times 13, 169. I must be getting close. 196. And 15 times 15, it has to be this one. 15 times 15 is indeed 225. Therefore, the square root of 225 is 15. Right. The last concept we're going to review is cube roots. So, cube roots are, for instance, the cube root of 8 is 2, because 2 times 2 times 2 is 8. You're now multiplying a number 3 times. And the cube root of 27, 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. So the cube root of 27 is 3. The cube root of 64, 4 times 4 is 16. 16 times 4 is 64. Cube root of 64 is 4. That's the idea of what a cube root is. Now we're going to find the cube root of a couple of different numbers. Let's start pretty easily. What's the cube root of 1,000? What is that? So I'm going to start this one with 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Obviously, it's going to be bigger than 5. I might as well try 10. 10 times 10 times 10 is 1,000. 3 zeros, right? Maybe you saw what the answer here was right away. So the cube root of 1,000 is 10. I didn't need my calculator for this one. It was an easy one, right? But what about the cube root of 2,197? What about that one? So why don't I start with 1,000? 10 times 10 times 10 is 1,000, right? Now I probably realized that I don't have to go much further. Let's try 11. 11 times 11 times 11, 1331. Now the odds that it's not going to be 12 are very slim, right? 12 times 12 times 12. 1728. I guess the odds weren't quite that good. Let's try 13. 2197. So the cube root of 2,197 is 13. 13 times 13 times 13 is 2197. Let's do another cube root. The cube root of 8,000. Obviously, it's got to be way higher than 10. 10 is 1,000. Let's begin with, let's try 20 first. 20 times 20 times 20. Oh, lo and behold, that's what it is. One step, we were done. 20 times 20 times 20 is 8,000. Cube root of 8,000 is 20. Well, let's do a harder one then. That one was easy. Cube root of 3,375. So obviously, if I look at the previous information that we already have, the cube root of 1,000 is 10. The cube root of 8,000 is 20. So 3,375 is going to be somewhere in between the two. Now, look back here. The cube root of 2,197 is 13, so it also has to be something bigger than 13. So why don't we begin looking at, based on our previous information, why don't we try 14 first? $27.44. $33.75. It is indeed 15. The cube root of 3,375 is 15. That's all the concepts I needed to review with you. So your assignment, will count for marks, is on page 149. Assess your understanding. Number 2, do 2 of the questions. There's number 2 has 6, pick 2 of them. Number 3, again do 2 of the questions. Number 4, do all of them. 3 different fraction exercises. Number 6, where you're finding square roots, all of them. And number 7, where you're finding cube roots, all of them. Now, if you've paid any attention at all to the review that I just did, once you start working on page 149, you will very quickly realize that I used some of the questions as examples. So some of the questions you'll be doing on page 149, you will find them in your notes.